Most of us treat an empty aluminum can the same way. We crush it, drop it in a bin, and move on, assuming it is finished. But in the United States, that can is not waste at all. It is valuable industrial material. Every year, more than 50 billion aluminum cans move through an industrial system worth tens of billions of dollars, supporting hundreds of thousands of jobs across the country. Once discarded, each can enters a tightly engineered network designed to move faster, cleaner, and more precisely than most manufacturing supply chains. In that system, a used can return to a store shelf in about 60 days, not as a different product, but as the same metal, reused again and again. When I first looked into what actually happens to these cans, I expected a simple recycling story. What I found instead was one of the most efficient material loops in modern industry. Please take a moment to subscribe and like the video. It really helps the channel. Aluminum is not just another metal. When it is recycled, it keeps nearly all of its original properties. It does not weaken or degrade. A can be recycled almost endlessly. The real difference is energy. Producing aluminum from raw ore is one of the most energy-intensive industrial processes on Earth. Recycling aluminum uses about 95% less energy. That single fact turns recycling into an industrial necessity. Across the U.S., recycled aluminum saves enough energy each year to power several million homes, while cutting costs for manufacturers at the same time. The United States operates one of the largest aluminum recycling systems in the world. The full aluminum industry, from recycling to finished products, contributes roughly $170 to $180 billion to the U.S. economy every year, and supports around 650,000 direct and indirect jobs. This system does not rely on one giant plant. It works because of a nationwide network. Collection begins in homes, offices, factories, stadiums, and public spaces. From there, aluminum moves through sorting facilities, processing plants, remelt furnaces, and rolling mills. This is a profit-driven industrial supply chain that feeds major manufacturing sectors across the country. When aluminum reaches a recycling facility, it arrives mixed with plastic, paper, steel, glass, and food waste. Sorting must happen fast and with precision. Modern U.S. facilities process tens of thousands of tons of material every day using layered systems of machines. Magnets remove steel. Screens and air jets separate lighter materials. Aluminum then reaches eddy current separators, where rapidly spinning magnetic fields push aluminum away from other waste streams in fractions of a second. At scale, this technology allows facilities to recover millions of pounds of aluminum every week. Once separated, aluminum is shredded and cleaned. It becomes industrial feedstock. This scrap is sent to remelt facilities, many running 24 hours a day. Inside furnaces operating above 700 degrees Celsius, shredded cans melt into liquid aluminum. Across the U.S., recycling plants process more than 3 million metric tons of aluminum scrap each year. Impurities are removed and alloys are carefully adjusted. What leaves the furnace is controlled, high-quality aluminum suitable for demanding industrial applications. One of the biggest strengths of the U.S. system is closed-loop recycling. In this model, aluminum from used cans returns directly into new cans. Companies like Novelis, Alcoa, Ball, and Crown operate facilities where recycled content makes up 70% or more of new beverage cans. This keeps supply stable and costs predictable. For manufacturers, recycled aluminum is often cheaper and less volatile than primary aluminum tied to global energy prices. After remelting, aluminum is cast into slabs that can weigh more than 25 tons each. These slabs are rolled into ultra-thin sheets at high speed. Thickness is controlled to fractions of a millimeter. From there, aluminum moves to can-making plants, where billions of cans are formed, filled, and sealed. In optimized systems, the journey from recycled scrap to a new can on a store shelf can take as little as 6 to 8 weeks. The U.S. system stands out because of integration and efficiency. While the country does not recycle every can it uses, it still recovers well over 1 million tons of aluminum cans annually. Highly automated plants, shorter supply chains, and strong domestic demand make recycled aluminum a core industrial input, not a backup option. China produces and processes more aluminum than any country on Earth. By volume, it dominates global output. However, much of China's aluminum is still produced from raw materials using electricity generated largely from coal. This makes primary aluminum in China far more energy intensive. By contrast, countries like Germany and Japan achieve aluminum recovery rates above 70% through strict deposit systems and efficient collection, despite operating on smaller industrial scales. The United States sits between these models. Its total output is smaller than China's, but a much larger share comes from recycled aluminum. This reduces energy exposure, emissions, and dependency on new smelters. Recycling also protects U.S. industry from global disruption. When aluminum prices spike due to energy shortages or geopolitical tension, recycled scrap provides a domestic buffer. During recent supply chain shocks, recycled aluminum helped manufacturers avoid production slowdowns that would have cost billions of dollars. For many industries, recycling is now a form of insurance. The beverage can industry is the most visible beneficiary. Aluminum cans are among the most recycled consumer products in the country, and recycled content now dominates can production. The automotive industry is rapidly increasing its use of recycled aluminum. Modern vehicles already contain 250 to 400 pounds of aluminum, a figure that continues to rise as automakers push for lighter and more efficient designs. Construction and infrastructure benefit as well. Aluminum is widely used in facades, windows, rail systems, and public structures. Recycled aluminum can reduce the carbon footprint of large projects by up to 80% compared to primary material. Aerospace and advanced manufacturing also rely on recycled aluminum. When properly processed, it meets strict performance standards while lowering material and energy costs. A single aluminum can weighs only about 15 grams, but at scale, cans are one of the most valuable scrap streams in the economy. Because they use known alloys and are collected in massive volumes, cans provide a consistent domestic resource. Billions of cans each year reduce the need for new mining, long-distance shipping, and energy-intensive smelting. Despite its strength, the U.S. recycling system has a bottleneck: collection rates. While some states recover more than 70% of cans, others fall below 30%. This means billions of cans are still lost to landfills each year, even though the industrial capacity to recycle them already exists. This is not a technology problem. It is a system gap. Global demand for aluminum is expected to grow by more than 40% by 2030, driven by electric vehicles, renewable energy, and lightweight transport. New mines and smelters take decades to develop. Recycling fills that gap immediately. Much of tomorrow's aluminum supply will come from products already circulating in the economy. So the next time a can is crushed and thrown away, it may seem insignificant, but inside America's aluminum recycling system, that small object enters a vast industrial machine, one that supports hundreds of thousands of jobs, saves enormous amounts of energy, and keeps critical industries running. Some of the most important infrastructure in modern society is not always visible. Sometimes it starts with what we choose to throw away. Thanks for watching Unthinkable Build. We'll see you in the next one.